And here's some examples of how this upwelling looks like in temperature distributions. Okay, the seasonal coastal upwelling of the Arabian coast during the west monsoon. Okay, and then the top left shows you one image which actually is in grayscale, where the darkest color refer to the coldest water. Okay, so the dark area, white is you can see the coastline, different areas, and you can identify something we call an upwelling center. 20 degrees, okay, 20-degree water, and significantly colder than the ambient water. And whenever you see something like this, because there is no other mechanism than the upwelling that can produce this cold surface. And indeed, if you look at a vertical transect, which is shown above my head in colors, you can actually see the upwelling of deeper water into the euphotic zone. Just look at the 20-degree contour. Now that you know how to draw contours, you can easily, you could even create maps like this by yourself. You can see that the 20-degree, let's get the mouse activated here, the 20-degree contour actually sits offshore. 200, this is in kilometers offshore. It sits at 100 meters, and you can see it's moved to the surface. Okay? So I just told you about the oxygen minimum zone. Indeed, the upwelled water has very low oxygen content, but the mixing mechanism and the air-sea gas exchange brings in new oxygen into the water, and so oxygen is really no hurdle for the production of marine life in the surface layers of the air. You can also see one feature up here in the map, a warm water feature, which we have a region which is 27 degrees Celsius. And what is this? What is this area? Is this an error? Is this, No, it's not an error. This one is what we call an eddy. Okay? This one is an eddy which actually has a warm core. It's a warm core eddy, but you can actually see it includes it has a little bit of upwelling in its center. It's a little bit of upward displacement of the isotherm here in the center. Okay, this is an eddy actually that we can see. Alrighty-o.